All right, this is Dr. B, and we're here on Tuesday evening, November 7th. And so welcome to everybody that's here. Say hello in the chat so I know who's around. Always good to see familiar names and some new names as well. So you know how your teacher tells you should always check your work, and make sure your answers are reasonable. I didn't really check my work today, so I ended up scheduling this stream for 8:30 a.m., 8:30 in the morning when I wanted it to be 8:30 p.m. when I'm right here. So I need to check my work when I'm scheduling streams. So it's no different than chemistry, always looking twice, making sure something's reasonable and it works. And T6 FIFA Mobile is here. All right, excellent. Good to see it. Zero motivation. Uh-oh. Yeah, sorry, folks, that we're here in the morning. Like I said, I got AM and PM. I guess I just didn't look. It's probably what happened. So next time I will double check that. But tonight we're going to do net ionic equations and some solubility stuff. Oh, and it's Wednesday morning there for zero motivation. That's kind of interesting. So tonight we're going to look at net ionic equations and solubility. This is the type of stuff that just comes out throughout your curriculum, whether you're looking at colligative properties or chemical reactions, solubility, molarity, all that stuff, acids, bases. So we want to look and make sure you understand solubility, and then we can apply that to net ionic equations, which are really kind of a big thing in general chemistry. All right, anybody else here? It looks like we have 18 people in the stats, but only zero motivation, and T6 said hello. Rocco Boco, welcome. All right, let me switch over to my screen here. And so give this a try. You're looking at NaCl. We put salt in water. And sometimes you'll see the water put down here too. But since it's not reacting, it's just dissolving in water. I'm going to keep it up here. What happens? What are you going to get? And how do you know? All right, Crystal and Melissa and Stephen, excellent. Welcome, guys. Yeah, so what do we end up with when salt dissolves in water? All right, so the first thing you have to know is it even going to dissolve? How do you know if a solid and a compound even dissolves? So one way is you could look at a solubility chart here, and that's something where you could find sodium, Na, and chlorine, the chloride, go across, and you see that S there. That means it's soluble, so it's going to dissolve. And Stephen, I see you already know what it's going to dissolve into. So we know that it's going to dissolve in water. So that's the first thing that we need to know. The second thing is you got to know what the charges are on the ions. So this is real useful if you don't know this already. If we look at the periodic table, we have Na over here and Cl here, plus and minus. So like a lot of folks are saying here, we're going to get Na plus and Cl minus. And because it's dissolved, you want to write Aq after that for aqueous. So that's kind of the net ionic equation, or at least the start of a net ionic equation. And zero motivation, I don't think at this level you'd talk much about hydroxides or hydronium ions here. Probably would just write it out this way. All right, so let's see if you can do this one. I've given you some information here. What are you going to end up with calcium chloride, the solid, put in water? And T6 FIFA Mobile, hydrogen's always written as H2 because when hydrogen bonds, it'll bond to another hydrogen to fulfill its highest energy level. And the only way it really does that is at H2. So it's a more stable molecule. So you could look at your solubility table here and find calcium and the chloride ion again, and you can just go over and see it's going to be soluble. Calcium's right here. We know chloride's over here. And Tarkish, you've got it. You guys are actually really good at this stuff. A lot of students I work with struggle for this. So you put your Ca2 plus here, but the important thing is this 2, it means you have 2 of the chloride ions. So 2Cl minus, and they'd be aqueous. So be real careful when you're doing this. This 2 means you have 2 of these, so you have to say that you have 2 separate ones. They're dissolved, they're floating around. Yeah, so that's not so bad, right? I think I got another one for you here. This one, let's look at the solubility rules. So you have the table, but there's also all of these rules, that very general rules that you memorize. Teachers like you to memorize these. And you can use these rules to figure out solubility as well. So teachers might not give you this, but this is real helpful. Give it a try. So now, Jason, Loretta, any of you guys out there tonight? I don't see your names. You usually say hello. So if you just look at the table, you're going to see you get that insoluble. But you can also look here at the rules and find out that most carbonates are insoluble with a few exceptions. So we know that this is going to only give us wet calcium carbonate. Nothing's really going to happen to it. It's just going to be like it's just wet. Doesn't dissolve at all. Yeah. All right. So I wanted to show you guys something. I thought this was really kind of interesting. I was looking at this. I was reading a research article on this here. Let's see if I can get over here. And the research article talked about cyclic sighing. It's a form of breathing, and it's really cool because what you do is you breathe in through your nose kind of comfortably, and then you breathe in a little bit more, and then you breathe out through your mouth. Hey, Loretta. And what happens is you can actually watch. I have a heart rate monitor here, one of these watches on mine. And when I do this cyclic sighing type thing, my heart rate actually goes down. My stress goes way down. And when you're looking at learning, lowering that stress is really important. Because when you try to create memories and consolidate memories, if you're stressed, the brain just does not consolidate and record memories as well. You don't learn as well. So really kind of a neat technique here. So I'll show you how I've been doing it, and it really makes my heart rate fall down. So you breathe in through your nose, and then when you have a pretty comfortable amount, you try to breathe a bunch more. And then you just let it out through your mouth real slowly. And then you do it again. And I actually feel my heart slowing down when I do that. So when you're studying, if you do this every once in a while or before a test, you will perform better. You'll remember more, and you'll be able to recall information better. So kind of a cool technique to give yourself a little leg up on everybody else taking the test there or studying. So speaking of stress, here's the solubility rules in the table. And what I want to show you is that the rules and the table are the same thing. These are all based on empirical observations. Like somebody put some of this in water, say calcium carbonate, they saw it was insoluble, and they could create the chart. So if you look at elements like sodium or potassium, here's sodium right here, all of these are soluble, just like the rule says. Potassium, all of them are soluble, just like the rule says. So the rules actually come from observations like this table. Like, for instance, chlorides, bromides, or iodides. Mostly, these guys, I don't have iodide there, most of them are soluble. Where phosphates, most of them are insoluble. So when you look at solubility rules or a table, it's all based on just observations. These are just two ways to look at the data. I like this way because it's faster. But if I get one that I'm not sure of, I'll go use this. All right. So I want to give you this guide here. I usually just give, this is available to my members on my channel, but this is my net ionic equations guide. So I'm going to give it to you guys because you're here. And this is a guide that will really help you out if you're trying to learn net ionic equations. Here's the guide. It links all of my videos, like on net ionics or spectator ions or solubility charts. And then it just gives you a ton of step-by-step explanation and then practice. And then there's like 20 down here at the bottom, 20 practice problems for net ionics. All the answers have a video. So this here should help you out as you try to learn this. So you can download it or you can get it from that link I just put in chat there. So what I'd like you to do is to see if I can grab the solubility rules here. If we can do oxidation states. Yeah, Stephen, I did that once before. Remind me, I'll put a good link to a video in there, but yeah, we could talk about that at some point. So something weird happened to my screen here. All right, so these are the rules. If you're trying to do a net ionic equation, it's always the same steps here that you use. You always balance the molecular equation. So let's cover this up. You always balance the molecular equation. That's balanced. And then you write the states. So I have all the states written in using the solubility table, all that stuff there that we just did. But the hard part, the thing that messes all the students up, is splitting soluble compounds into their ions. And we worked with that a little bit. So see if you can split this one right here, sodium hydroxide, into your ions. And yeah, I do archive the streams. They're all, if you go under live on my channel, Dr. B's chemistry channel, you'll see all the streams there, Flipzilla. Yeah, so see if you guys can split this into its ions. Right there, sodium hydroxide. So remember, sodium was positive. This whole hydroxide is negative. I'll move this down for you here. Yeah, redox reactions, Melissa, I'm actually working on a guide for redox reactions, balancing them. It's hard. It's not super easy, but hopefully in a few weeks I'll have something for that. That's probably one of the toughest things in chemistry is balancing redox. All right, so you can see that I broke this up into two of these sodiums, and the 2 goes to the whole thing here, 2 hydroxides. And the copper sulfate, since it's aqueous, sulfate's always 2 minus, that has to be 2 plus. So you have to memorize your ions, your charges. We break that up. We break the sodium up again. And because we have 2 here, we got to have 2 sodiums here. But in net ionic equations, you don't break the solids apart because they're together, right? They're already stuck together. So you don't break them apart. And you end up with that whole net ionic equation here, complete ionic equation, I should say. Then what you can do is you have to cross out the spectator ions. So we have 2 sodiums here and 2 here. You just cross them out. What else do we have? Sulfates, cross them out. I think that's it. So we're left with this, and this is your net ionic equation right here. That's it. And the reason we leave it as this is these are the only things that change. These things here, they're the same on both sides. They didn't change, so we don't worry about those there. All right. Thank you, Harshan. I appreciate it. So what are some topics that you all would like to see me do in the future? I've heard redox tonight. What's something that's kind of really concerning you or giving you headaches that might be good for me to do in a stream here or create some videos for? I'd be really interested in hearing that. I do think that redox reactions are one of the harder things. Stoichiometry messes with people a lot. I see a lot of students that I've taught, when they see stoichiometry, you start seeing people drop classes. Neutralization or stoichiometry, right? Um, yeah, and so zero motivation. You are correct. This is the net ionic equation here. Um, the spectators would be sodium and the sulfate ions. Anything from Chem 103 module. So I don't know what Chem 103 is, to tell you the truth. So if there's a specific topic, let me know. Flipzilla, what kind of stoichiometry are we talking about? Can most people do moles to grams comfortably? Okay. Hamza, you have a good question. Transition. Okay. So how can I tell if the solubility of any compound, if it's aqueous or precipitate? If it's a solid, if you have a solid like this here, that's a precipitate. So we just use the rules that we were looking at. Yeah, transition metals are a pain because they have that d orbital, zero motivation. That makes them hard. So Hamza, this would be a precipitate because it's a solid, right? So if I go back up and I look at, let me grab the solubility rules here. So you can either memorize this table here. If you memorize the rules here, then anything that is insoluble is going to be a precipitate. So anything you see here that says I on this chart, that's a precipitate. I haven't done much with KSP, zero motivation. I think that's an interesting one. And wastewater management's very, very, very practical. And mustard orb, yeah, moles to grams. There's also one where I did that before in the, what do you call it? We did a live stream on moles to grams. You might check that out. It's pretty good. And in all of the live streams I did before, if you look at the description, you can get the videos I've already done. And they're a little more concise than me kind of stumbling around with my screen software and everything like that. Awesome. Well, I think we're coming up on about 20 minutes here, and that's probably about as long as you really want to study without a break. Once you get over 20 minutes, you start kind of, you don't remember as well, you don't focus as much. You only need a 2 to 3 minute break. And what you really should do on that break then is you should go up and do some cyclic sighing, which I think is kind of a bit of a hilarious term, but it really does work. Your heart rate goes down. That helps you focus. More oxygen to your brain. That's just some real key that's some really good chemistry going on in your brain. Melissa, you like acid-base titrations? Yeah. Balancing redox under basic conditions, it's the same as acidic. It's just one more step at the end, but I am working on a guide for that. So subscribe to my channel, and then when I publish, you should hopefully see a notification on that. Thank you, Mustard Orb. That really helps my channel, is when people recommend my videos. I think a lot of the growth I see comes from people recommending stuff to other folks. So I always appreciate that quite a bit. All right. Well, I think that's enough. If you look at the description of this stream, you'll have all kinds of links to the solubility and the net ionic equations. You have that guide. I hope those guides are useful for you. For net ionic equations, I really thought about that and worked hard to make that so it should be really strong. This Thursday, I won't be around. I'm traveling, so I won't be streaming this Thursday, but we'll pick up the following week. So as always, thank you everybody for joining me here. This has been, it's always nice to connect with you. And thanks for watching. I'll see you next Tuesday at 8:30 p.m. Eastern Standard Time, not AM. Thanks, and good night. Hey, Flipzilla, I just saw your comments. I don't have a lot of other study tips right now, but that may be something I start incorporating in my streams because I think some folks would benefit from that. And my specialty, as my PhD is in learning sciences. So my master's, my undergraduate's in chemistry, but my PhD is in learning sciences. So that's kind of my specialty. So I will talk to you all soon, and maybe I'll put some more learning tips, study tips in there. Take care, everyone. There we go.